Right, I've got an inverter up here, 2nd of July, bit of data. Sun comes up at around 8 o'clock. State of charge 20%, 90%, 8 o'clock, 90, or virtually 8 o'clock, 19%, and by 11 o'clock it's fully charged, sitting there at 92%, which is maximum charge really. So you can imagine, you could get, this is the middle of winter too, and so you can imagine it's a sunny day, I guess. No, Monday wasn't. Monday was okay. It wasn't fantastic. It was overcast a lot. So if this is winter, you could charge 2 batteries fully on an very average day, 3 on a sunny day, and have all that stored for the night. We're talking about a 5.6 kilowatt hour GCL battery here. So there's plenty of room for more batteries. This array can handle it. Let's look at the other inverter, which is there. Very, very similar graph as you'd imagine. They're on the same roof more or less. And there's the charge rate, very similar, about 8 o'clock or so. And did I hit the same bloody inverter? That's 39. No, this one, yeah, it's fully charged by 10:50. Yeah, very similar, 8 o'clock till 11 o'clock, fully charged. And here's this light blue section, that's the PV power, charging the battery, and after it's fully charged it starts exporting. Maximum export here, 4.976. It's got an export limiting control of 5 kilowatts, and that's necessary because there's 2 inverters with 2 arrays here. Go back to the other one. Is that it? No, it's the same one as on. Gee. Here we go. This one peaks at 4.67 kilowatts. The meters are taking instantaneous readings, perhaps 30 seconds apart or so, or every 10 minutes, who knows. But they don't line up perfectly, but you get a very similar graph, just the same. As you can see, I can't distinguish much between the 2 inverters. So that's that. Let's go back to the 1st of July, very important, on both inverters. And as you can see, the batteries weren't discharging until I fixed the data cable. Here I am turning it off and on again. So, but now that it will discharge, it comes to about 4:10, we have full power, and then boom, it's flat by, well, it's mostly flat by 7:20 and fully flat by 8:30. Now we'll look at the other one, which is this one here, I think. This one starts discharging later at 5:40, and it's flat by 8:30 or so, right? And if we just flick between the 2 graphs, it's pretty much a sharp decline, but one starts earlier than the other. The reason is they've both got a current transformer clamped on the same consumer's mains, and they don't know each other's there. So when this one decides to take off, this one decides to start discharging to stop import of power. The other one sits there fully charged, like here, going, oh, there's no power being used, I won't discharge. But after a while they start to take it in turns. Let's look at 6 o'clock here. This one's discharging now at 2.3 kilowatts. Where's the other one? Here. This one's doing nothing. It's doing 54 watts, which is just some, what would you call, fluctuation. It's not really discharging. So, and for whatever reason, there was an instantaneous usage of power of 739 watts. Probably something got turned on and the inverter needed a few seconds to adjust. And if we go to 6:10, as you can see, virtually no power being used, 112 watts, but that's probably just, as I said, fluctuations. and it's doing nothing. This inverter now, which was doing all the load earlier, because it's the one that started at 4:10 to discharge after the sun went down. Here we are at 6:10. If we go to the other inverter at 6:10, it's doing all the work. It's discharging at 2.3 kilowatts, and the load is virtually the same apart from a few fluctuations, as I said. So they seem to be discharging at a rate of knots here. At some point, look at this green graph. This green graph is usage. At this point, there's 4.4 kilowatts being used. And if we go to the other graph, is this the one? It peaks at a usage of 5 kilowatts. It's a massive drain. So these batteries are doing their job and they're going flat quickly, but they're saving a lot of money in the meantime. And then by the time it's 8:30 or so, they're out of power. So that graph would be half as steep and last till midnight if there was 2 batteries per inverter. And there's a heavy load on this house. Remember, there's already 2 batteries here. So it's just the nature of how they discharge. They seem to take it in turns, and that's why you get, a buy power of 2.4 kilowatts here, and a drainage of 2.2, and a load of 4.4. And I know that doesn't add up, but they're instantaneous readings, and they change all the time. The readings change all the time, but they're ballpark figure. So that one's doing all the work at 6:30, whereas this one at 6:30 is doing nothing. As you can see, it's saying, "Oh, I don't need to turn on." It's the other one's cloaking all of the load. So that's how these things work. So when they're on the same house, but they're doing their job, which is good. And last of all, to finish off, it says there's a charge power here, but as you can see, the state of charge stays at 19% the whole time. That charge power is a fluctuation of some sort. It's only 36 watts. On the other inverter, this state of charge stays at 15%. That's no problem. Alright, there's a token charge power of 100 watts, but I think that's just the 0 point is not set properly. Well, it's not that it's not set properly, it's just that there's fluctuations all the time. But overall, it's not charging at night. That's good. It's sitting there at 15% after doing its evening work, and the other inverter, and then come the next morning, it sits there again at 15%, and then doesn't start charging until the morning. Likewise, I change the date now to the 2nd. Again, the same. I don't know what happened here, but there's no record, no communications. If we go, that's worth noting. I don't know what happened here. Never up when the internet was reconnected. There's data not here. I don't know why. Let's go to the 3rd. This there was readings taken until the internet was turned off. The Wi-Fi was turned off, and it hasn't updated ever since, because it hasn't been turned on ever since. And that can also be seen here. The other inverter. So it's all working well. It's just that there's a hell of a load on this house, but it's doing its job and it'll save money.